Hey everyone, welcome to today's Explainer. Look, if you're trying to wrap your head around how modern data platforms are actually built under the hood, you are exactly where you need to be. Today, we're literally going to break down Snowflake's cloud-native architecture layer by layer and demystify what makes this whole platform tick. Let's get right into it. So here's our roadmap for today. We'll hit 1, the self-managed data platform, 2, the hybrid architecture, 3, 3 core architecture layers, 4, powering your data workloads, 5, AI and machine learning, and finally, 6, SnowGrid and connectivity. Okay, let's dive into this.
Section 1, the self-managed data platform.
Okay, so this is the foundational premise of Snowflake, right? It's a system natively designed for the cloud from day one. And honestly, this setup is exactly why IT decision makers absolutely love it. When we say self-managed service, it means you literally cannot install Snowflake locally or on a private cloud. Instead, it uses public cloud infrastructure to handle all the heavy lifting for you. There's no physical hardware to select or manage, and virtually no software to install or configure. The whole shebang, ongoing maintenance, upgrades, tuning, Snowflake handles it. For engineering teams, this is a real game changer. It means you can completely escape local installation headaches, avoid the absolute pain of managing physical servers, and just focus entirely on what actually matters, deriving value from your data.
Moving on to Section 2, the hybrid architecture.
Now, this is where Snowflake really breaks the mold of traditional legacy data warehouses. Let me throw a question out there for you. How do you combine the best of a shared disk and a shared nothing architecture? I mean, for decades, database engineers have essentially had to choose between simplicity on one hand and massive scale on the other. But what if you didn't have to choose?
Well, Snowflake actually solved this exact problem, and it's brilliant. Just to recap quickly, the traditional shared disk approach uses a central data repository that's accessible from all compute nodes, right? Which gives you fantastic data management simplicity. Conversely, the shared nothing approach uses massively parallel processing compute clusters, MPP, that store data locally, giving you incredible scale-out performance. What Snowflake did was build a true hybrid. You get a central data repository for your persisted data, but queries are processed using independent MPP compute clusters. So you're literally getting the absolute best of both worlds, the simplicity of shared disk and the raw horsepower of a shared nothing system.
All right, Section 3, 3 core architecture layers.
So, now that we've got the big picture, let's peel back the floorboards of this metaphorical house and look at the 3 specific layers that make this hybrid system run. We've got 1, database storage, 2, compute, and 3, cloud services. Let's take a quick deep dive into each one. Starting off with the database storage layer. The defining word here, flexibility. Snowflake natively handles structured data, your strict tabular rows and columns, but it also handles semi-structured data with flexible schemas, think JSON or XML files, and perhaps most impressively, unstructured data with no inherent schema at all, like documents, images, and audio. Snowflake just handles all of these right out of the box.
And within that storage layer, you actually have 3 distinct options. First up, standard Snowflake tables. These are internally optimized and perfect for your classic data warehouses. Second, we've got Apache Iceberg tables. Now, this is huge if you already have existing data lakes, say external cloud storage sitting in Amazon S3 or Google Cloud, and you want to query that data without actually having to move it into Snowflake. Super convenient. And third, hybrid tables. These are optimized for low-latency random reads and writes, seamlessly bringing your analytical and transactional workloads together into one single platform, which they call Unistore.
But before we move on from storage, we really need to talk about how the data is actually organized. Enter the micro-partition. Whenever data is loaded into a Snowflake table, the platform automatically divides it into these internally optimized, compressed, contiguous units of storage. It's like a giant puzzle, but you don't even have to put it together yourself. You don't manage file sizes, structures, or metadata. Snowflake's storage layer handles all of that automatically within these micro-partitions to make sure your queries run as efficiently as possible.
Okay, moving up to layer number 2, compute. In Snowflake, compute power is provided by what's called a virtual warehouse. Now, this is just an independent compute cluster that processes SQL statements and runs your Snowpark code. But here's the crucial point right here. Because these clusters are independent, they do not share resources with one another. This means a massive, super heavy query run by your data science team on one virtual warehouse will have absolutely zero impact on the performance of the finance team's virtual warehouse. No more fighting for resources.
And finally, we hit the third layer, cloud services.
Honestly, you can think of this as the brain that coordinates everything across the entire platform. It handles it all, from your initial sign-in all the way to query dispatch. It manages security, authentication, and access control. It runs the Snowflake Horizon catalog, manages the metadata, and takes care of query parsing and optimization. Basically, the storage layer holds your data, the compute layer is the muscle doing the heavy lifting, and this cloud services layer is the traffic cop directing the whole show.
All right, moving on to Section 4, powering your data workloads.
So our foundation is built. Now let's explore the rooms built on top of this architecture and see what engineers and analysts can actually do. Because Snowflake separates storage from compute, the traditional headaches of infrastructure management just kind of fade away. This lets your data engineers focus entirely on the data lifecycle itself. Check out these steps. Step 1, ingest. You can use simple commands like copy into, or even continuously load row-level data with Snowpipe streaming. Step 2, transform. You can easily define dynamic tables that refresh themselves automatically, or do some really complex transformations using Python or Java in Snowpark. And step 3, analyze. Dynamically scale your workloads and leverage aggregate functions, window functions, and common table expressions to pull real actionable business value.
But listen, it goes way beyond just querying tables. We're talking about building interactive web apps directly for machine learning and data science using Streamlit. You can deploy and scale containerized applications right inside Snowflake using Snowpark Container Services. You can even build native apps, securely share business logic with other Snowflake accounts, or collaborate using data clean rooms. And the best part? All this happens directly where your data already lives. You completely avoid that old, painful headache of keeping data synced across a bunch of disjointed external systems.
Which brings us to Section 5, AI and machine learning.
Speaking of doing things right, where your data lives, let's explore one of the absolute most exciting capabilities built into the platform. Now, what's really interesting here is the sheer breadth of top-tier intelligence you literally have at your fingertips. Snowflake's Cortex AI functions let you run unstructured analytics using large language models from industry giants. We're talking OpenAI, Anthropic, Meta, Mistral AI, and DeepSeek. You get the incredible power of these cutting-edge LLMs without the massive cost and complexity of dragging your sensitive data out into some separate third-party AI environment. It's all right there.
To clarify exactly how Snowflake approaches AI, let's look at two distinct paths for data teams. On the left, Snowflake Cortex. This is your out-of-the-box automation. It uses those LLMs we just mentioned to understand unstructured data, answer free-form questions, and automate simple summaries or translations fast. On the right, we have Snowflake ML. This provides a unified environment for true custom development. This is where your data scientists can dig in, perform feature engineering, and build, train, and run their very own custom machine learning models right alongside the data. So you're covered whether you want quick automation or deep custom modeling.
Finally, Section 6, SnowGrid and connectivity.
We are in the home stretch. So how does this massive architecture actually scale geographically and talk to the outside world? The answer is SnowGrid. This is Snowflake's ultimate cross-region, cross-cloud technology layer. SnowGrid lets you seamlessly connect a data ecosystem across different cloud providers. It genuinely doesn't matter if you're using AWS, Microsoft Azure, or Google Cloud. It ensures you can apply consistent security and governance policies globally. And perhaps most importantly for enterprise stability, it enables cross-region disaster recovery and business continuity through replication. It's absolutely crucial. And of course, you've got to connect your human users and your existing software stack to this powerhouse, right? Well, Snowflake offers incredibly versatile connectivity. You can manage everything through the Snowsight web user interface. If you're a developer, you can jump into the Snowflake CLI or tap into native Python and REST APIs to manage resources programmatically. Plus, thanks to some really robust drivers, it plugs seamlessly into your existing IT stack. It plays perfectly with third-party ETL tools like Informatica and BI tools like ThoughtSpot. Wow, okay, we have covered a tremendous amount of ground today. We peeled back the layers from storage and compute all the way up to integrated large language models. So I want to leave you with a final provocative thought to chew on. How will your organization harness this highly scalable, self-managed architecture and the integrated power of Cortex AI to transform your own data ecosystem? The tools are right here, built natively into the cloud. Thanks so much for joining me on this explainer. Keep learning, keep asking those big questions, and I will see you next time.